I'd like to show you how the mirage or miroscope optical illusion works. The mirage is made from two curved mirrors. When we place an object facing away from us inside the mirage and then replace the top mirror, a real image facing towards us forms on the top. We can understand why this happens by exploring the properties of parabolas. A parabola can be defined using the Cartesian equation y equals x squared over 4f, where f is the focal length of the parabola. However, the parabola can also be defined using a reference point called the focus and a reference line called the directrix. The focus sits at a height f above the origin, while the directrix lies at distance f below the origin. The parabola consists of all points that are equidistant from the focus and directrix. Here we see colored line segments starting from the parabola growing towards the focus and directrix at the same speed. Line segments of the same color are the same length. When a line segment touches either the focus or directrix, it flashes. Each line segment grows at the same rate, and each pair of lines starts from the same point on the parabola, touches the focus and directrix at the same time. A mirror shaped like a parabola is called a parabolic reflector. When a light source is placed at the focus, the light rays that bounce off the parabolic reflector travel together in parallel, sort of like a searchlight. Conversely, light rays traveling parallel to the axis that bounce off the reflector pass through the focal point. If the light rays start at a point that is above the focus and strike the reflector near the base, they will converge at a point called the real image of the point source. We can use this to understand how the mirage illusion works. The mirage is formed from a pair of parabolic reflectors. The focus of the top reflector is located at the base of the bottom reflector and vice versa. The object that's placed just above the base of the bottom reflector forms a real image just above the base of the top reflector. When a light on the object flashes, the light that bounces off the top reflector is directed to the bottom reflector and is brought back to a point on the real image. Heuristically, the light from the object starts near the focus of the top reflector, so it forms parallel rays that are sent to the bottom reflector. When the parallel rays hit the bottom reflector, they converge to the proper point on the real image. Notice that the real image is inverted. Right and left are flipped. The image that forms above the mirage is called a real image because it optically acts as though it really existed. If I take a laser pointer and aim it at the real image of the plastic frog, the laser beam scatters off the image as though it were really there in front of the laser. I can move the laser pointer back and forth, and the laser beam scatters off the image as though the plastic frog were sitting on top of the mirage. So, how exactly does this work? Well, when we aim the laser towards the real image at an angle to the vertical, the laser beam doesn't scatter off the real image. Instead, it passes into the mirage, is reflected off the bottom mirror, then the top, and finally strikes the object. The light scattered from the object travels back up, first striking the top mirror, then the bottom, to converge at the point where the laser beam intersects with the real image. The light then emerges from the real image as though the laser beam had scattered from it. As we move the laser beam back and forth, the light rays continue to track the point of intersection. It appears that the laser beam is hitting a real object. Notice that when the right side of the object is illuminated, the left side of the real image is illuminated and vice versa. Everything still stays aligned because the laser beam undergoes two sets of mirror image reflections. It looks like the laser acts as though the real image was really floating above the mirage, but something odd happens when the laser is pointed straight down at the object. This time, when we move the laser pointer back and forth, the spot on the object moves in the opposite direction. So, why does this happen, and what's going on with this? Well, the laser beam shines directly onto the object, in this case, without first striking the curved mirrors. Since the real image is inverted compared to the real object, the laser spot on the real image moves in the opposite direction compared to the laser spot on the object itself. So, it appears backwards. Well, here's a puzzle for you to solve. If we shine the laser pointer at the frog and then slowly move the pointer towards the frog, we see that instead of striking the frog, the laser pointer suddenly starts to glow. Can you figure out why this happens? Thanks for watching.